The idea of function composition is to combine two related functions into a single function. The idea of function inversion is to make a function which reverses the process of another function. Let's start with an example function composition. Suppose at your job you earn $8 per hour, so we might write that as a function that our income after X hours is equal to 8X. A related function is that you pay a flat income tax of 5%. This function we might say that the tax on X dollars is 0.05 times X. It's important to note that X means two different things depending on which function I'm talking about. In the income function, X represents hours, and in the tax function, X represents dollars. We should be able to combine these two functions into a single function that tells me the tax I would have to pay on X hours of work. This is why I think such a function should exist. Imagine I've worked 40 hours. I could determine how much money I made in 40 hours by using the income function. I make $8 an hour, and I've worked 40 hours, so 8 times 40 is the $320. And now that I know how much money I made in that time, I can compute the tax with the tax function. I've made $320, and I paid 5% of that as tax, and so I have a $16 tax. So leaving out the intermediate step of computing the income, I might just say that the tax on 40 hours of work is $16. But there ought to be a single function that computes this. Another way to look at it is to say that the income function turns 40 hours of work into $320 of income. The tax function takes $320 of income and turns that into $16 of tax. And what we're looking for is a single function, capital T, that takes 40 hours of work and turns it directly into $16 of tax. Let's carry out the same logic, but just with an arbitrary X hours of work instead of 40 hours. The income function says that the income I make for X hours of work is 8 times X dollars. If I now take the 8 times X dollars that I've made and substitute that into the tax function, then I see that my tax is the 0.05, that's the 5%, times the 8X dollars that I've made, which becomes 0.4X dollars in tax. So the tax on X hours of work is 0.4X dollars. But this is exactly what our capital T function is supposed to do. It's supposed to take an arbitrary number of hours of work and tell me directly how much tax I'll pay for that many hours of work. If we think of the picture again, the income function turned X hours of work into 8X dollars of income, and the little t tax function took the 8X dollars of income and turned it into 0.4X dollars of tax. Our capital T tax function begins with X hours of work and sends it directly to 0.4X dollars of tax. So what we've just done is composed the function little t with the function little I to create a single function which performs the actions of both of them in succession. The way we created the capital T function, which begins with X hours and should give us the tax paid on that work, was to first apply the income function, which turned hours into dollars of income, and then apply the little tax function that we knew, which turned dollars of income into dollars of tax. So notice on the right-hand side, the income function is nested most deeply in the parentheses, indicating that it should be performed first, and then the little t function should be applied. So if I ask for the income after X hours, which is the meaning of I of X, and that's 8X dollars, and then if I ask for the tax on 8X dollars, that's 0.05 times 8X. The function little t is being evaluated at 8X. And simplifying the numbers is how we came up with the 0.4X. So now an example of function inversion. If I know that a cheese pizza costs $12 and each additional topping is $2 extra, I can make a linear function that tells me the cost for a pizza with X toppings. I have to pay $12 no matter what, and then I pay $2 for each additional topping, and I come up with an equation of 12 plus 2x. So this function begins with the number of toppings and tells me the cost. Could I make a function that goes the other way around? A function that begins with the cost of the pizza and then tells me how many toppings are on it. What about an $18 pizza? How would we determine how many toppings must be on this? I know that the relationship between cost and toppings is this function c of x is equal to 12 plus 2x. Remember in this function that x represents the number of toppings and c of x is the cost. So I can substitute on the left-hand side the $18 cost and solve for the number of toppings. I would subtract 12 on both sides, divide both sides by 2, and I know that there are 3 toppings on this $18 pizza. In this example, the cost function would begin with 3 toppings and turn that into an $18 cost, whereas the toppings function that we're trying to create should begin with an $18 cost and turn that into an answer of 3 toppings. Just as we did before, let's start with an arbitrary number of toppings. I know that cost and toppings are related in this way. Just to keep ourselves from getting confused about all the different meanings of x, let's just rewrite this as cost c is equal to 12 plus 2 times t, the number of toppings. I can solve this for t in just exactly the same way as we did before. I subtract 12 on both sides, divide both sides by 2. Now I have the relationship between cost and toppings expressed in a different way, that the number of toppings is equal to the cost minus 12, all divided by 2. But this is exactly the function we were looking for. If I just rewrite this in our usual function notation, I can say that the number of toppings, t of x, on an $x pizza is x minus 12 all over 2. While our cost function began with x toppings and turned that into a 12 plus 2x cost, our new function t begins with an $x cost and determines that there are x minus 12 all divided by 2 toppings on the pizza. In this example, the function c and the function t are inverses. C goes from toppings to dollars, and t goes from dollars back to toppings. So the inverse of any function f is a different function that undoes the action of f. I should note that f to the minus 1 is just notation. It has nothing to do with negative first power. A more precise way to say that f inverse undoes the action of f is that if I start with x, and then apply f, and then apply f inverse to the result, that I should come right back to x. The function f will send x somewhere, and the function f inverse will bring that value right back to x. And if you compose them in the reverse order, the same thing happens. F inverse will send x somewhere, and the function f will send it right back to x. So we claim that the cost function and the toppings function were inverses of one another. And we can use the definition to check that that's actually the case. So remember that the cost function takes a number of toppings and tells you the cost of that pizza. And the toppings function begins with the cost of the pizza and tells you the number of toppings. So if I begin with x toppings and ask how much does that pizza cost, and then take that cost and ask how many toppings are on it, I should end up with x. So the cost of a pizza with x toppings is the 12 plus 2x. Since that's most deeply nested in the parentheses, I evaluate that one first. If I apply the toppings function to the input 12 plus 2x, then the x in our generic definition of the toppings function becomes 12 plus 2x instead. If I apply the toppings function now to the cost 12 plus 2x, then that function takes the cost, which is 12 plus 2x, subtracts 12, and then divides the entire expression by 2. If I begin to simplify this, I have 12 minus 12, which cancels out, and I have 2 divided by 2, which cancels out, and leaves me with x, as we expected. If instead we plug the toppings function into the cost function, we write out the definition of the toppings function and say that the number of toppings on a pizza that costs x dollars is x minus 12 over 2, and then we ask the cost of a pizza with that many toppings. So in the definition of the cost function, our value for x is now x minus 12 over 2. The 2 divided by 2 will cancel out, and then the 12 minus 12 will cancel out and leave us with x as we expected.